Algebra 1, Chapter 3, -3, or Section 3-3, rate of change and slope. Rate of change and slope. What is rate of change? This is how much one quantity changes in relation to another quantity changing. How much one quantity changes in relation to another quantity changing. For instance, actually we're going to do a for instance in just a minute. Before we do that, we're going to look at what an equation might look like, having to do with the rate of change. So the way we do this is we put the change in y, which is up and down, over the change in x, which is left and right. Let's see what we're talking about here now. Find the rate of change. So we've got the number of computer games. So you're going to go buy some computer games. So here's the number of computer games. And we're going to just say these are all the same price. And we're going to say, we're going to call these X. And we're going to call the cost, total cost, we're going to call that Y. All right. So if you buy 2 computer games, it's going to cost you $78. If you buy 4 computer games, it's going to cost you $156. If you buy 6 computer games, it will cost you $234. Now, let's look at these as points on a coordinate plane. So your x value would be 2, your y is 78. When x is 4, y is 156. So this is x and this is y. And down here, this is 6, excuse me, 234. Okay, so let's go ahead and let's graph this. We'll just kind of somewhat roughly graph it so we can see that this is a line. And so the x is going to be the number of games. Number of games. And the y value is going to be the cost. So let's just go like this. So we've got at 2, we've got at 4, and we've got at 6. And then let's put the cost over here. Let's do like this. We'll do kind of big ones, and we'll just say this is 78. And we'll say this is 156, and we'll say this one is 234. Okay, so at 2 we go to 78, at 4 we have 156, and at 6 we've got 234. So here's our line. At 0 we should be at 0, right? But go like that. Okay. Now, as you can see in this rate of change, how much one quantity changes in relation to another quantity. So what we're saying here is my rate of change is that, let's say I have 2 games at $78. If I want 4 games, so I've changed my quantity here, my X value, I've changed the number of games, so my cost is going to go up as well. So this value changed when this value changed. So that's what we're talking about with rate of change. So rate of change is how much it goes, how much it changes. When one quantity changes, how much does the other quantity change? It's the relationship between those two. Now, the way we calculate the actual rate of change is we say this is x1 and this is y1, and then we choose another point, x2 and y2. We label those, and then we use something we call the slope formula. So we say m is the slope, and we say y2 minus y1 over x2 minus x1. This is the slope formula. Memorize this thing because we're going to use it all the time going forward. Notice y2 minus y1, that's the change in y. Notice y is going up and down. The change in x is x2 minus x1. That's left and right. And so that's change in x underneath change in y. So the first thing we always do when we're doing finding the slope, we label our points, x1, y1, x2, y2. All right. Now, let's plug those points into this formula here. So y2 is 156, y1 is 78, so we're going to subtract those two. And then x2 is 4 minus x1, which is 2. And so now I've got 156 minus 78, which is 78. 4 minus 2 is 2. 78 divided by 2 is 39. So the rate of change for this particular problem here, the number of computer games and the total cost, the rate of change is 39. So that's $39 per one game. Let's do another example. We've got a number of floor tiles. We're going to call that X. And the area of the tiles, or a total area. How much area do these tiles make up? And we're going to call that Y. So for 3 tiles, we've got 48. For 6 tiles, we've got 96. And for 9 tiles, we've got 144 is our area. All right? So we want to find the rate of change. Find the rate of change. I'm just going to say ROC like that. And we're also going to try to explain the meaning, kind of like we did up here. Explain the meaning. There's going to be a question like this on that test, or potentially. All right, so let's just write these out as points. 3, 48, 6, 96, and 9, 144. Now, we're going to use our slope formula. We're going to choose 2 points to use in the slope formula. And 3 is going to be my x1, and then y1 will be 48, x2 is 6, y2 is 96. You can use this one too, but those numbers are bigger, and I don't want to add and subtract those. I choose these ones. They're a little bit easier. So y2 is 96, y1 is 48, x2 is 6, x1 is 3. So now I've got 96 minus 48, which is going to get me 48. 6 minus 3 is 3. And now 48 divided by 3 is 16. So my rate of change is 16. That means for every tile, my area is going to be 16 whatever inches squared or whatever more. So each tile is worth 16 the area is 16, whatever it is we're talking about here. Let's do one more. Oh, let's do the next section here. The next section is decide whether the function is linear Okay. Now, if it's going to be linear, that means it's got a constant rate of change. Constant rate of change. So let's figure out another way we can find the rate of change, and we can test to see if it's constant. So we're going to look at a couple examples here. We're given a t-table here that is, the x values are 1, 4, 7, 10, and 13. The corresponding y values are -6, -8, -10, -12, and -14. So this is how we check to see if this is a linear function. We just go from 1 to 4. That's +3. From 4 to 7, that's +3. From 7 to 10, that's +3. And from 10 to 13, that's +3. Okay, so as far as the x value goes, we're all just looking at adding 3. So that's good. Now, if these values are going to be all the same as one another, then we know the rate of change is going to be constant. So let's see if that's true. -6 to -8, that's -2. -8 to -10, that's -2 again. -10 to -12, that's -2. -12 to -14, that's -2. So the rate of change between these 2 points is -2 over 3, y over x. Same with this one, -2 over 3, -2 over 3, -2 over 3. So yes, this is linear, because we have a constant rate of change. So this would be -2 over 3. Let's look at another one. Yeah, let's look at another one. -3, -1, 1, 3, and 5 are your x values. Now your corresponding y values are 10, 12, 16, 18, and 22. Okay, let's look at the x values first. -3 to 1 is +2. -1 to +1, that's +2. 1 to 3 is +2, and 3 to 5 is +2. All right, so all of our x values are moving at the same rate. All right, so now we can look at the y values and see if they are also moving at the same rate. 10 to 12 is +2. 12 to 16 is +4. Oh, that's not good. 16 to 18 is +2. And 18 to 22 is +4 again. So we can see that there's a difference here between 2 and 4. So our slope, or our rate of change between these 2 points, -310 and -112, is 2 over 2. But our rate of change between these 2 points, -1 and 12 and 1 and 16, is 4 over 2. So these ones have 2 over 2, this one has 4 over 2. The rate of change is not the same, so these are not linear. Let's look at C. So for C, we are given a chart, or just a graph. And this graph looks like this. Now, is this a constant rate of change? Notice how it goes up, steady, 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 then it goes down a little bit, so my slope changes, and then it goes back up again. This is not a constant rate of change, so that means this is not linear. Let's have you do one on your own, and see how you do, and then we will check your work directly afterwards. -6, -3, 0, 3, 6, and 9 are your x values. Your y values that correspond to those x values are 1, 3, 5, 7, 10, and 12. All right, see if your rate of change is constant, and therefore decide whether this is a linear function or not. Okay, pause and go. All right, let's see how you did. So you should have looked at this -6 to -3 and said that's +3. -3 to 0, that's +3. 0 to 3 is +3. 3 to 6, +3. 6 to 9, +3. Okay, we got a constant rate here of movement for the x values. Let's see if the y values are the same. 1 to 3, that's +2. That looks good so far. +2. 3 to 5 is +2. 5 to 7 is +2. 7 to 10 is +3. And 10 to 12 is +2, sorry. So here we have a problem, and that is enough to tell us this is not linear. It only takes one to mess up the whole bunch. All right, let's keep on moving. Kind of a lot going on in this section. Slope. We're going to talk about slope. We talked about slope a little bit already, but we're going to talk about it a little bit more. Slope refers to how steep the line is. Slope and rate of change can generally be used interchangeably. How steep the line is. And we can also say that this is rise over run. So rise up and down, or y, over run left and right. Again, we're going to write down our slope formula. Slope is change in y, which is y2 minus y1 over x2 minus x1. Okay, now there is one thing that I want to show you here, over here on the right. And we've looked at how to use this formula, and we're going to do that again very soon. But there is a trick that you can use if you have a very clean and clear graph. So let's just say I've got a very clean and clear, easy to read graph. And I've got, so draw something hopefully like this, and I've got a line that goes, let's say, from here to here. All right. So I can clearly see that there's a point right here that is 1, 3. And I can clearly see that there's a point right here that is 2, 0. Now, I've got these 2 points. I could label them x1, y1, x1, y1, and x2, y2, and I could find the slope using this formula. Now, there's another way to do it if you have an easy, clean, and clear graph. And that is, I can just count over 1, and then down 1, 2, 3. So if I go over 1, that is my run, so that would be 1, and then my, and that would be in the denominator, rise over run. So my rise would be 1, 2, 3, -3. I'm always looking left to right. Always read left to right. Left to right. So I have +1 and then down 3. So my rate of change, or my slope, is -3 over 1, which is just -3. That's my slope for this line. So that's a kind of a trick that you can use if you have a graph that's very easy to read and very clearly you can see where the points are. That's not always the case. So more often than not, you might see something more like this. Find the slope. You might find something like this. -2, 0, and 1, 5. You're just given 2 points, and you're told, find the slope. And you say, I don't really feel like it. And then I say, it doesn't really matter if you feel like it. You got to do it anyways. And then you say, okay, fine, I guess I will. And then this is how you do it. The first thing you do is label x1, y1, x2, y2. Now, you can label this one x1, y1, and this one x2, y2. It doesn't matter, as long as each point is either 1s or 2s, not both. Okay, hopefully that's not too confusing, but we're just going to do this. So remember, my slope formula is y2 minus y1 over x2 minus x1. So let's just plug in these values. y2 is 5, minus y1, which is 0, x2, which is 1, x1 minus x1, which is -2. Careful, x1 is -2, and you're going to subtract -2 from 1. So I always put my parentheses here so that I can make sure I'm doing this correctly. And now I've got 5 minus 0 is 5. 1 minus -2, which ends up being 1 plus 2, is 5 over 3. So that's my slope, 5 over 3. Now let's do this just to see what happens. -2, 0, and 1, 5. These are the points that we just found the slope for. Let's call this x2, y2, and x1, y1. Oh no, Mr. V, that sounds crazy, but we're going to do it anyways. And so y2 is now 0. So notice how these are both 2s and these are both 1s. This should still work out okay. Let's see if it does. Y2 is 0, y1 is 5, over x2, which is -2, minus x1, which is 1. Now I've got 0 minus 5, which is -5. -2 minus 1 is -3. Negative divided by a negative is a positive, so I have 5 over 3 equals m. Dun, dun, dun. Let's move on. -3, 4, 2, -3. Find the slope. All right, we'll do this one together, and then I'm going to send you off on your own. Let's see. First thing I do, label x1, y1, x2, y2. Next thing I'm going to do, plug these into the formula. y2 is -3 minus y1, which is 4, over x2, which is 2, minus parentheses, -3. So remember, we're looking for the slope here. This is the slope formula. -3 minus 4 is -7. 2 plus 3 is 5. This is my answer. -7 over 5 is my slope. Now you do, I'm going to have you do 2. -3, -1, 2, -1, find my slope. You try another one, -2, 4, and -2, -3. All right, do those two, and we are going to come back together and see how you did. Okay, go ahead and pause and do these two. Go. All right, welcome back. Going to label first, x1, y1, x2, y2. Always label. Don't take a shortcut here. It's going to help you tremendously. -1 minus -1 over 2 minus -3. All right, -1 plus 1 is 0 over 2 minus -3 is going to give me 5. 0 over 5 is 0. So this is 0 slope, meaning that if I were to have a graph of a line, it would look like this. It doesn't go up or down, it's just straight across, zero slope. It doesn't change. The slope doesn't change. Now let's see what you got on this one. x1, y1, x2, y2. So y2 is -3 minus y1, which is 4. x2 is -2 minus a -2. All right? -3 minus 4 is -7. -2 minus a -2, so that's -2 plus 2. That becomes 0. Oh no! We are not allowed to have 0 in the denominator. This is undefined or no slope. Now it's not zero slope, it's no slope. It's a little bit different. Okay? And what that means is that I have something like this where the line goes in a vertical direction, direction. So it's at x equals a number, and there is the line. That's what's happening when I end up with 0 in the denominator. All right, last little bit here. Hopefully we can get this in on time. Slope formulas. Examples, sorry. Slope examples. So we're always reading left to right. Remember we said that a little bit before? So if I have a coordinate plane, and then I draw a line that goes like this, left to right, it's going up. This is a positive slope. Let's look at another one. I've got a line going this way. Left to right, my line is going down. This is a negative slope. And now I'm going to redraw these ones that we just looked at. I have a line that goes like this, something like y equals 1, 2, 3, 4, 5. This is 0 slope. So y equals a number, whatever it is. Your slope equals 0. Now, last one. This is the undefined one. And this is where 1, 2, 3, 4, let's put it here at 4. This is x equals 4. This is undefined or no slope. And this is when the denominator ends up being 0, x equals 4, x equals a number. And that is the end of 3-3, rate of change and slope.